Next, some formulas. Integral e power ax sin bx, which is equal to e power ax by a square b square into a sin bx minus b cos bx. Integral e power ax cos bx dx, which is equal to e power ax by a square plus b square, a cos bx plus b sin bx. We'll see the next problem. Given that process x of t has the autocorrelation function r of tau, which is equal to a e power minus alpha modulus tau cos omega naught tau, where a greater than 0, alpha is greater than 0, that is alpha small, and omega naught are constant. Find the power spectrum of x of t. Given r, that is autocorrelation, you have to find the power spectrum s omega, right? So given autocorrelation r, which is equal to a e power minus alpha modulus tau cos omega naught tau, right? That is equation number 1. We know power spectrum is the Fourier transform of autocorrelation. So Fourier transform of r xx of tau, which is equal to minus infinite to plus infinite r xx of tau e power minus I omega tau d tau is equal to substituting r value from equation number 1, minus infinite to plus infinite a e power minus alpha modulus tau cos omega naught tau e power minus omega tau d tau. So grouping e powers, so a is constant, taking outside the integral, minus infinite to plus infinite e power minus alpha mod tau plus I omega tau. Minus is common, so taking minus outside, right? So cos omega naught tau into d tau is equal to a integral minus infinite to plus infinite. We are splitting the integral in two forms. First, negative side, that is minus infinite to 0, then positive side 0 to infinite, because in the negative side modulus tau, which is equal to minus tau, and in the positive side modulus tau, which is equal to tau plus tau, right? That is what we are using, those ideas. So in the integral, so a into minus infinite to plus infinite e power minus alpha, so this is negative part, so you are replacing modulus tau by minus tau plus I omega tau cos omega naught tau d tau plus positive part 0 to infinite e power minus alpha plus tau plus I omega tau cos omega naught tau d tau. So this is equal to integral minus infinite to 0 e power minus alpha plus I omega, tau is common, take it outside, into tau cos omega naught tau d tau plus 0 to infinite e power minus alpha plus I omega into tau into cos omega naught tau d tau. So this is equal to a into e power minus alpha plus I omega tau by minus alpha plus I omega the whole square plus omega naught square into minus alpha plus I omega cos omega naught tau plus omega naught sin omega naught tau. Limit is minus infinite to 0, because here we are using the formula there, e power ax, second formula, cos bx. So a is minus alpha plus I omega a, b is omega naught tau, right? So replacing those things, you will get this answer, right? Similarly, for the second one, the same formula, a into e power minus alpha plus I omega tau by minus alpha plus I omega square plus omega naught square minus alpha plus I omega cos omega naught tau plus omega naught sin omega naught tau 0 to infinite. So this is equal to, we are substituting upper limit and lower limit. So you will get a e power a I omega 0, that is the upper limit there in the first integrand, minus alpha plus I omega square plus omega naught square, a alpha minus I omega cos omega naught into 0 plus omega naught sin omega naught 0 minus upper limit, replacing 0 by minus infinite, the same thing, plus the second integrand upper limit plus infinite. So we are replacing tau by infinite in all, right? Minus lower limit is 0. So replacing tau by 0 in the integrand. So you will get this expansion, right? We know cos 0 1, e power 0 1, e power minus infinite what is 0. So we are substituting those value. So e power 0 1 by minus a I omega square plus omega naught square alpha minus I omega cos 0 1 into omega naught into sin 0 0 minus 0, right? Because e power minus infinite, whatever it is, 0 into that expansion plus a into e power infinite 0 again into that expression minus e power 0 1 by a plus I omega square plus omega naught square minus alpha plus I omega into 1 cos 0 1. The last term I am talking about, plus omega naught into 0. So we will get a into the remaining term alpha minus I omega, the first term, the above expression, a into alpha minus I omega by minus alpha I omega square plus omega naught square, right? First term. And then the second term, a into minus, because minus is there, right? Minus alpha plus I omega, right? Divided by a plus I omega square plus omega naught square, correct? The second expression, the second term, right? In the first expression there are two terms, right? A into, there are two terms. I am taking the first term, second term becomes 0. The second expression, a into first term becomes 0, second term is minus of something is there, no, that is the thing, right? So which is equal to a into alpha minus I omega minus alpha plus I omega square plus omega naught square plus a into minus into minus plus alpha plus I omega, alpha plus I omega square plus omega naught square. So taking the LCM as usual. So we are cross multiplying and taking the LCM, right? So which is equal to alpha plus I omega square plus omega naught square plus alpha plus I omega minus alpha plus I omega square plus omega naught square. In denominator we are using the expression, right? Alpha square a minus b whole square minus alpha plus I omega square, we are using a minus b whole square formula. So alpha square a square plus b square I omega square minus 2ab minus 2I alpha omega plus the next term omega naught square. Here a plus b whole square formula, I am talking about the denominator term. So alpha square plus I omega square plus 2I alpha omega plus omega naught square, which is equal to a into, so we are splitting the terms in the numerator. First multiply alpha into alpha I omega square, alpha into omega naught square minus omega square plus omega naught square minus 2I alpha omega. Similarly the second term alpha square minus omega square plus omega naught square plus 2I alpha omega, right? So this is equal to a into alpha square plus I omega square plus 2I alpha omega plus 2 alpha omega naught square minus I omega alpha square plus I omega square plus 2I alpha omega plus alpha into alpha square plus I omega square minus 2I alpha omega plus I omega alpha square plus I omega square minus 2I alpha omega. Denominator alpha square minus omega square plus omega naught square the whole square minus 2I alpha omega, because we are using the formula a plus b into a minus b. So a square minus b square. Instead of a you are having alpha square minus omega square plus omega naught square. Instead of b you are having 2I alpha omega. I am talking about the denominator. Is equal to a into, so again full expansion, alpha cube minus alpha omega square plus 2I alpha square omega plus 2 alpha omega square minus I omega a alpha square plus I omega cube. We are multiplying each and every term, right? We are removing the bracket on the numerator. So we will get plus etc plus 2 alpha omega square as then denominator. So which is equal to a into, after simplification, a into numerator 2 alpha cube plus 2 alpha omega square plus 2 alpha omega naught square. Denominator alpha square minus omega square by plus omega naught square, the whole square, plus we know I square is equal to minus 1. So minus already there, minus into minus plus 2 squares is equal to 4. So alpha square omega square. Therefore, the power spectrum density Sxx of omega, which is equal to A into taking 2 alpha common in the numerator. So 2 alpha into alpha square plus omega naught square divided by the denominator. Thanks. We'll see in the next video.